So today's project is to make a 240 volt power pack out of odds and ends I've got kicking about. One is a 12 volt battery which I've liberated from a faulty Halfords power pack. But the most important thing is this little inverter which takes 12 volts in and allegedly gives 240 volts out. It'll be interesting to see if it even works. And something to put it all in a box which has been kicking about with an old power supply in it which I've chucked out because it's not needed anymore. So the first thing I need to do is see if this inverter actually works, because without that we're gubbed. So I've connected it all together in a highly professional manner, of course, and we'll see what happens. What we're looking for is minimum smoke and no loud bang. I've already checked the battery and it's giving 12.5 volts. I've got a fuse in there, although it's pretty high, so it might still give a loud bang. Let's light the blue touch paper. Okay, light come on, no smoke. That's a good sign. Moment of truth is to plug something into it and see what happens. Well, shock horror, it works. So now we need to try and fit it into the box. So I now have a plan of action and where everything's going to fit. And this is hopefully what it will look like. Big chunky switch on the front, along with probably that fuse holder and maybe even a wee voltmeter and ammeter. And a couple of terminals so I can charge the battery without opening up the box. So we now need to start drilling holes and making a lot of noise. So I've now made a bracket which will hold the battery in, and the next job is to make a cutout on the panel so that this so that's the hole cut for the main socket. It's not exactly perfectly square, but to be honest, a blind man running for a bus on a dark night wouldn't notice. So the bracket to hold the inverter is now in place, and the next job is to fill this hole on the back of the box. So that's that patched up. And while it's sitting, I think it's time for a wee cup of tea. So the next job is to paint the box. The choice of colour is boring grey because that's what I have. So while the paint is drying, I'm going to look at the front panel, and this is more or less how it's going to be. On-off switch, fuse, small switch for turning on the inverter, charger inputs, the voltmeter, ammeter, and a couple of switches for LEDs that are going to be on the side, but I don't actually have them yet. So more drilling holes. So the front panel is now all drilled out. I'm going to give it a spray paint. So the front panel is now painted, and the next thing to do is to put all the bits in it. So one of my favourite phrases is that the man who never made a mistake never made anything. And as you can imagine, this is leading up to a confession of what we call a balls up. So the switch here is fouling on the inverter. You might also notice that the same cowboy that decided where the switch was going was a wee bit heavy with the file, and it required a wee dod of glue to hold some of the switches in. Anyway, every problem has a solution, and in this case it's a different switch, wee bit of metal to cover the hole, and a dod of glue. So the front panel is all back together now. I've added in another switch here which doesn't foul at the back. Put a little plate on here to hide the hole. I've also added a fuse there on the charging input, which we'll also use for a 12-volt output. I decided that was probably a good idea. So we're all ready to wire it up now, and to remain professional as ever, I have a schematic, which I may or may not follow. So the wiring of the box is nearly done, and I've now got my LED all the way from China, and I've found that it's got an on-off switch on it. So that means I can get rid of the two on-off switches on the front panel. So the plan is to put the LEDs on the side, around about there. So I need to drill a wee hole on the side to get the wire through. So the wiring is all done and it's back together, and I switched it on and there was smoke. And this is the remains of the wire that was smoking. The insulation has separated. This is the multimeter I used. It's as cheap as chips. I didn't get any instructions with it, and the mistake I made was not to go online and look for them. So it turns out that the thin black wire shouldn't be connected if you're powering it via the same thing that you're measuring the load in. The schematic shows how it should have been wired. So it is now working. That gives the battery voltage, and that's the current. So if I switch on one of the side lights, You'll see the current goes up, although to be quite honest, I take that with a pinch of salt, what that reads, but it's close enough. And if I plug something in to the back, which gives mains voltage out, switch this on, and the light comes on. And that's reading 4 amps. Well, I've got a 10 amp fuse in here, so I really don't want to go any higher than that. So it will take a few LED lights, and that's about all. The inverter is capable of going up to 200 watts, but the battery won't last long if I go up that high. So I just need to put the case back together and put a few labels on the front, and we're good to go. So the box is all back together now. I've got some labels on the front, and I'm now going to test it with a 100-watt light bulb, which is about the limit it can go to. And this is an old style filament light bulb, which you don't see many of these days. So that's it, just powered up, not the inverter on, showing batteries at 12 volts, 12.4. If I switch the inverter on, makes an interesting singing noise, but at least it is lighting the 100-watt bulb. And it's reading 11 amps, which is higher than I really would want to go. But I'm quite pleased that that actually does work. So what it's also got is LEDs on each side, so it can be used as just emergency lighting if there's a power cut. But it's not going to last very long if I power very much via the mains on it. So that's it. Now I just need to wait for a power cut.